Now here we've got a sum to infinity sigma notation question. And it's not one of those straightforward questions where you're given the sigma notation and you need to get the sum. But instead, we notice that we're actually given the answer of the sum, and we have a variable that we need to solve for. So this is what we're given, and they say solve for m, and it's for 4 marks. Now what I need you to remember is that whether it is a level 2 or a level 4 question, you start off with your usual method. So what we do is we start off by calculating the first 3 terms from the starting term. So here underneath the sigma notation, it says n is equal to 1, meaning that we're starting from term 1. So we're going to calculate term 1, term 2, and term 3. Now remember, you are substituting into m. So it's going to be 63m to the power n minus 1, so 1 minus 1. 63m to the power 2 minus 1. 63m to the power 3 minus 1. Let's simplify what we have. So 1 minus 1 is 0. You will have m to the power 0, and anything raised to the power 0 is 1. So that is just 63. Then the second term, 2 minus 1 is 1. M to the power 1 is just m. 63 m to the power 3 minus 1. So 3 minus 1 is 2. For our third term, we have 63m squared. Now that's our starting point. We get the first 3 terms from the starting term. Thereafter, we would need to determine a. Since this is sum to infinity, it's a geometric series. So we would need to determine a, r, and n. But in this case, remember, n is infinity because it goes up to infinity, right? And the thing is, we have one extra bit of information with this question, which is the answer. We know that for sum to infinity, the answer is 189 over 2, because that's what's given to us on the right-hand side. So we know that is 189 over 2. That's the extra bit of information that we have. So remember that a is the first term that you calculated. We have 63. Now to get r, you can take the quotient of any 2 consecutive terms. So I'm going to use the second term and the first term. 63 over m over 63. What happens here is the 63's cancel out. So r is actually m. Now once you have a, r, and n, you are ready to write down your formula. So we're dealing with sum to infinity. That is a over 1 minus r. On the left hand side, we were given the answer. So we know that the sum to infinity is 189 over 2. On the right hand side, we're going to substitute what we have. A is 63 over 1 minus, and r here is equal to m. Now our aim is to solve for m. But we cannot solve for a variable if it's in the denominator. So we need to get it out of the denominator. And here's an important rule in maths. It says that when you have an equation and you have a fraction on either side, you are allowed to cross multiply. So this is essentially what cross multiplying is. But part of cross multiplying here is that it allows you to take the numerator of one fraction and the denominator of the other fraction and make them swap places with each other. Doing so here, we would have 1 minus m now in the numerator on the left, and we would have 189 in the denominator on the right. Then at the same time, we're going to take this 2 from the denominator and multiply across with 63. That gives you 126. And now to get m alone, we can take the 1 over to the right hand side, or since m is negative, let's take the m over to the right, and let's take this fraction over to the left. Now yes, you could have kept the negative m on the left and then divide by the negative throughout afterwards, but I'm just saving us one step by doing it this way. Now simplifying the left-hand side, we end up with m is equal to 1 over 3. So that is the value of m. Now we have question 3.2, and it says, if it is further given that m is 1 over 3, and yay, that is what we have. So we know that this is right. Determine the smallest value of n such that Tn is less than 1 over 6,561. Now firstly, this Tn that they have on the left actually comes from your sigma notation. Remember that next to your sigma notation, that expression represents Tn. That is the general formula. So on the left-hand side where we have Tn, we can replace it with 63m to the power n minus 1. But now since we know what m is, we can actually have 63 times 1 over 3 to the power n minus 1. So that's how we're going to start off. So here we have it. There's the question. We replaced Tn with the general term, and we replaced m with 1 over 3. Now your aim here is simply to solve for n. So we want to get rid of the 63. We're going to divide both sides by 63. So here's what we get. When we divide both sides by 63, on the left it cancels out. On the right hand side, 1 over 6561 divided by 63, and this is what you get. Now you know that when you have the variable as the exponent, your aim is to get the bases to be the same. So ideally, we would like 1 over 3 raised to the power something that's equal to this fraction. However, we can try playing around with this, and you can try this as well on your calculator. 1 over 3. We're going to raise it to quite a few powers to check if we get this. But the problem is that we are not able to get any exponent of 1 over 3 that gives us this fraction. So if we cannot, if it does not work out, we have log. So here we will have to introduce log. And remember that the aim of log is to bring down this exponent so that you can make it the subject of the formula. So we're going to bring down this exponent, and immediately on the right hand side we are going to introduce log. Now whatever was the base of the exponent becomes the base of log, and in line with log we will have the fraction that was alone on the right hand side. So let's actually put this in our calculator to get a value. So this is what I get as a decimal. When I put that in on my calculator, I get 11.771243,749. And now to solve for n, we are going to take this 1 over to the right hand side. It is going to add, so this value becomes 12.771243,749. Now remember, this is not an equation. This isn't telling us that n is equal to 12.77. But this says n is less than 12.77. So the nearest whole number smaller than 12.77 is 12. So we will conclude by saying, therefore, n is 12. Please remember that when it comes to inequality questions, you have to actually select your final answer based on the sign that you're working with. Say that instead this was a greater than sign. Then our answer would have been n is equal to 13. But since it's a less than, we're going to take the nearest whole number smaller than 12.77, which would be 12. So that is your final answer. Please remember to like, subscribe, and turn on your notifications for more content.